Welcome to Data Viz with Class. I'm Caleb Class. I'm Caleb Class. Ugh. I'm Caleb Class. Today we're going to try something new. We're going to do a little data improv. I'm going to do this because there's all these people out there making data science tutorials. They make everything so tight and clean and perfect. We do this, then we do that, then we do that, then we get a beautiful graph and the conclusions make sense and everything is just perfect. Real data science is not like that. Sometimes the data is messy, the analysis is tricky, the graph looks like shit. All that's okay. All that is normal. Maybe the result of your analysis is there is no real result. There is no conclusion. And that's okay too, because you tried and you learned something. Maybe you can go talk to some friends, figure out what went wrong, get better next time. So on this show, we're going to try to make nice graphs. You can see the thought process behind what graphs I decide to make, how I try to make them. You can see what happens when I can't figure out exactly what to do, when I need to figure out how to make the graph, or when I do make the graph and it doesn't come out quite right. And hopefully this way, we'll learn some stuff together. Maybe we'll make some nice graphs. Maybe we'll make some graphs that don't look so nice, and you'll also get to see me have a mental breakdown. That's okay too. Today I'm going to look at comedy movies. I love comedy movies because it feels good to laugh. It's a natural stress reliever. The goal today is to ask and answer the question, are there really less comedy movies than there used to be? We've got a data set from IMDB that gives the basic details of basically every movie released over the past 100 years or more. We're going to look at this data set. I think it'll help us answer the question. So I got two kids, so I get to maybe see one grown-up movie a year and the rest are kids movies. Let's see, I think Inside Out 2, loved them both. Inside Out 2, basically the story of my life. They based the character anxiety off of me. I think like all the kids movies, maybe in the 90s, that's when the kids movies stopped being like really scary. Like before that, the whole point of a kids movie was to like give you nightmares. Like I saw Pinocchio when I was 6. They like all turn into elephants and animals and stuff. I was terrified. I don't know, that's like all my movie memories. My whole life. It's embarrassing. Like, I don't think this is going that well. What do you think? What do you think, YouTube? Siri, how do I get funnier?
Some tips for becoming a funnier person include practicing joke telling, taking comedic risks, and watching, listening to, and reading the work of comedians. This is from psychologytoday.com.
What are examples of comedic risks?
This could include pranking children into believing their parents are dead, threats or advocating for physical or psychological harm against oneself or others, such as laying flat between train tracks. This answer is from google.com.
How many of those are illegal?
Okay, I found this on the web for how many examples of those are illegal. Check it out.
Okay, thank you, Siri. So today we are going to first load in our data set. You can find it in the episode description if you would like to follow along. Mostly focusing on this title basics data set. I got the title ratings data set just in case we need it. I should go to that website and show you. IMDB. Non-commercial data sets. All right, so you are not allowed to modify and then post this again for commercial gain, and I will not do that either. We're just going to do a little analysis. Okay, so you can see there's maybe 8 data sets in here. 8 data sets in here. The ones we are going to focus on, title basics. Well, let's go to our title AKAs. We've got origins. And actually, maybe we should download that too because it gives you the region. We'll see if we need it. Maybe we'll come back. Maybe we'll need title AKAs too. This one that I started with, title basics, every title back to the 1800s. The type, so we got movies, but we've also got these other things too. The primary title, the original title in the original language, the year, some other stuff. Genres, very important because we are looking for comedy movies. Crew, not going to worry about that. Episodes, we're only looking at movies. Ratings, maybe we'll take a look at user ratings. All right, let's get started. Here we are in RStudio. I'm in version 4.4.2. You can use whatever version you like. And you can see that we loaded these data sets, or we have these data sets. We haven't loaded them yet. Let's go ahead and load the tidyverse first, as always. There we go. You know, we always get a few conflicts. These are okay. Unless you get a whole bunch of red text that says you get an error, everything is working fine. Now, these .gz, that's gzip, kind of like a zip folder. You know what those are. We could always unzip those in our file browser, but we can also unzip those in R. So, unzip files. Well, let's see, do we have gunzip or is that a different library? Nope. Where's gunzip? I forget. Let's remind ourselves, gunzip in R. Stack Overflow, big fan, not a sponsor, but they are always good. Okay, we want to unzip for zip. So this was just getting it ready, but we can call gz file and then read dot whatever from there. Very neat. Okay, let's make sure I got gz file ready to go. I do. Let's give this a try. Basic data frame is read.table. Is it read.table, or you could do read TSV too. Maybe let's try read TSV from the tidyverse. See how that works for us. And then we're gonna go gz file. I'm gonna hit enter so we got space. We need to find the file. You could always find it over here. Let's just go. So you can see I'm in this whole thing. I'm in the DVC folder. If you need to change what directory you are in, there's all different ways to do it. You can do it over here. Look up YouTube videos on how to do that. But I am where I want to be. We just need to find the data set from here. So we're in the Improv /IMDB folder. And the data set is title.basics. Let's just see if it works. Pretty big data set. Importantly, if you want to follow along, type everything I'm doing in R, please do that. If you want to check out my tutorials before doing that, do that too, that'd be great. Remember, you can pause, you can go back, you can go through slowly, you can try to understand what every line is doing. That is going to make you become a better data scientist. But if you don't want to do that, you're just trying to absorb it, getting our first exposure, that is great too. I'm happy to have you. There will be a link to code in the episode description. Now, if I go up here, looks like it worked okay. How many rows? That's a lot of rows. 11 million rows, 9 columns. Why don't I go ahead and save our script, and we'll call it movie analysis. Next, let's go ahead and view, or even, yeah, let's just do view. View whatever I called it, view basic data frame. So this kind of ID should let us link to other data sets if we need to. You can see we've got different types of titles. Let's just do a table of that. Basic df $title type. Actually, why don't I copy that to the script? And we are just interested in the 706,000 movies that have been made. We'll even leave out the TV movies. So that'll be one filter we're going to do. Also, we're going to leave out the adult movies. No judgment. So the movie DF should be filter. Let's use the pipe. Basic DF pipe filter. Title type should just be movies. Now you can see we've gone from 11 million rows down to 700,000 rows. That is good. If we look at movie DF, they're all 001s. We have been moving the 9,000 adult movies. Again, no judgment. Movie DF. We are going to filter those out. All right, so we could do is adult not equal to 1. This is a fun fact. When we have zeros and ones, that is the same as true false. So we're saying we just want this to not be 1, or we just want it to be equal to 0, or we could also do not is adult. That exclamation point is not. By saying not this, it removes the ones, it keeps the zeros. And just to make sure I'm right, they're all zeros now. Okay. Also thinking, do we remove the children's movies? Good question. This is a decision that maybe could go either way. Children's movies can be comedies. They could also just be children's movies. They could also be different kind of movies. A children's adventure. That's not really a comedy. But anyways, I'm going to leave in the kids' movies. So I'm not filtering out the kids' movies. Let's see what we got now. View movie DF. These movies go back to 1894, Miss Jerry, a romance, the Corbett Fitzsimmons Flight. Is that interesting? I don't know. I bet these movies were pretty boring. Like you could see this Edison kinetoscopic record of a sneeze. I would like to watch that.
From the Library of Congress in Washington, D.C. This has been a presentation of the Library of Congress. Visit us at loc.gov.
That was good. So we are including foreign language films, which might skew the analysis one way or the other. If you have a better way to do this, let me know in the comments. We'll take a little look online to see if we can find a better data set. We can find a better data set, or if we can see someone who's already done this analysis. Somebody's probably already done this analysis. I haven't looked at it yet, but we'll look at it at the end to see if anybody's already beat me to it. So let's just use the whole data set. Let's just start by looking at table, movie, DF, dollar, genres. And you can see there are a whole lot. They don't just put one, they put multiple. This one is a documentary history horror. Here is a documentary war western. All right, so we don't just have these nice clean categories, comedy, drama, documentary. A lot of things are more than one genre. So we will have to take that into the account. So why don't we just make a quick plot, how many movies over time. The start year is going to give you the release year. End year is in there for TV shows. When did the TV show end? But for movies, we're just going to worry about start year. So total movies over time, or movies released each year. And that'll be an easy one. Just make the line graph showing of trends over time. So ggplot movie df. Nope, we need to count movies each year. So let's take movie DF, pipe it into group by start year. Note that we start typing the column name. It gives us a suggestion. And all we need to do now is count, and we get start year, and then N is the number of movies. And then we can send that into ggplot, and our X will be start year, Y will be N, plus geom line. That is all there is to it. Or I thought that was all there is to it. What a mess. Okay, let's see what happened to start year. Start year is a text variable. We don't want that. So why don't we take movie DF? We are going to mutate that. That could mean, might not, could mean that there is some text in that. In that case, we would get some NAs, and that's okay. We'll just leave those out because we're lazy. And instead of start year, we'll call it year. We could call it release year. Let's just call it year equals as numeric start year. Now we are forcing this to be numeric. We can see how many of these end up being NA. NA means there was something besides a number in that column. So if it says 1999 in quotes, it's just going to turn it into 1999 number. That is what we want. If there's a word there, it is going to turn that into an NA because it cannot turn a word into a number. So how many of these are NA? Mute, no, movie, DF, dollar year. Decent amount. Okay, so are we going to be lazy? We're going to figure out why that happened. And they just don't have release years. That's another flaw of the data set. Or maybe they were never actually released. So that's another thing to know. So why don't we go ahead and filter out? We do not want things where there's no release year. Movie DF down to about 600,000 rows, 600,000 movies. We are now going to group by year. So now it's a number. We got lines. We'll take it. What is that huge drop? So let's see what happened. We get this huge spike, then it comes way, way down to almost 0. So let's do this group by and count. And I just want to see the result. I'm going to arrange by N. N is the number of movies. No, that's not what I want to do. I'm going to arrange by year. And I would actually like it to be descending year. So I want to look at the last years in the data set. And it looks like these are probably planned releases. So I'm going to cut it off at 2024 because this data set was updated in 2025, but it's not everything from 2025. So we got another filter to do. I'm going to go back up here and just add that to this filter. So we want it to be not NA, but also and year is less than or equal to 2024. Because we don't want planned releases, we want things that have been released. And now we can see it goes up and up and up. That's a little drop during COVID. Most likely we could check that to make sure. And then it continues. All right, let's see how many comedy movies there have been per year. And you remember, there are things that might just be comedy movies. Let's just say some. How many just say comedy? So movie, DF, dollar, genres equals comedy. 40,000, that's a lot. There might be a lot that are comedy, but also something else. We want those to count. So how would we do that? You know something called a regular expression. They are amazing. You can do a lot of things with those. There's also a tidyverse version of those. Forget what it's called. So potentially I would use grep, G-R-E-P, but I know there's a tidyverse version. Let's use that. Tidyverse version of grep. String R is like the version. And we might want to use string detect. Inside the genres column, it's going to look for the word comedy. That's what we're going to tell it to do. And what we could do is we could set up a new version of our data set with a new column using mutate. This is going to say, we'll just make a new column called is comedy. We'll use string detect genres. We're going to detect the pattern comedy. Table, movie, DF, dollar is comedy. We have 100,000. It used to be 40,000. We've got 100,000 that have comedy somewhere in them. So one thing we could do just to check in case we've got some lowercase, we could put something called a fixed function around it. And then we could say ignore case equals true. And 101,554, it's exactly the same. So it didn't matter. We could copy our code from before, make your line graph. There it is. Comedy movies over time. In this case, we would filter, and since is comedy is a true false variable, you can see it here, we can just put is comedy. So if it is a comedy, it'll be true, it'll keep it. If it's not, it'll be false, it'll remove it. And then this will be comedy movies over time. And basically we see the same type of pattern because there's been a ton more movies overall. There's also been a ton more comedies. So this doesn't help us that much. Maybe the number of comedies has gone up, but the proportion of comedies has gone down. Maybe we want to look at that. And obviously we would want to add some stuff like a nice title. We're just going to say comedy movies over time. And let's just say count or number of movies. We'll make it more special later. For example, by doing an area plot. Area plot's nice for a lot of different things. For example, we could just turn this into an area plot and that would be fine. Be kind of boring. Geom area. Now it filled in the line. Make it a little 3D if we wanted to. 3D generally not recommended, but sometimes it's fun. But one thing that's nice is using an area plot to show proportion. Say comedy, drama, and others. We want to see if one starts taking a higher proportion of the movies over time. So to start, maybe I would just show, say, comedy versus other. because it's going to be kind of complicated. We've got movies that can be considered multiple categories, so it's not really easy to just split it up to different genres. But we can say things that are comedy versus things that are not comedy. And that'll actually be pretty simple. So we're going to look at the proportion of comedy movies over time. We can start by copy pasting. So we don't want to filter is comedy anymore, but we are going to group by those things. So group by year and is comedy. This will give us the count of each. Why don't we see what that would look like if we do that? See, we can see in 1894, actually there were no comedy movies at the beginning. In 1900, there were 6 not comedy movies. There was 1 comedy movie. And so for every year, it's going to say how many not comedy movies, how many comedy movies. Then we have our year, we've got our count. We will fill the area plot by, is it a comedy or not? And there we go. This shows us a little more. So this shows comedy movies and other movies. And you can see the same increase. Comedy is definitely the minority of movies, but it's hard to see how much the fraction has changed going from here to here. So it's easier to just calculate the fraction. So there's 2 ways to do this. We could just have the area plot show us the proportion. That's a little sneaky trick. We could also do a group by and summarize, a summary calculation that calculates how many were comedy movies each year. So let's check area plot R add up to 1. Area plot R proportions. A proportional stacked areas chart. Thank you, R graph gallery. Oh, this one actually just has you calculate it. So maybe there is just one way to do it. I thought there was a way you could do it in ggplot. All right, we're just gonna do it the group by and summarize way, and that's okay. So to do it using group by and summarize, we're not going to group by comedy anymore. We are going to summarize. Mean is comedy. So using the mean function on a logical expression, that tells you what fraction of those are true. And let's show an example of this. So if we just look overall, table, movie data frame is comedy, you can see 101,000 are, 487 are not. We could calculate this ourselves by taking 101,554 divided by the sum of these 2 numbers. About 17% overall in this data set are comedy movies. If instead we say mean movie DF is comedy, exact same number. The reason is that R treats true as 1 and false as 0. So it is taking the average of all the 1s and 0s. The nice thing is that the practical meaning of that is when you have a bunch of true falses, the mean says what fraction of those are true. Multiply it by 100, you get what percentage of those are true. So that can be useful for a whole lot of things. Say what fraction of the movies came out after 1980. So year, greater than equal, whatever. About 70% of all the movies in this database, apparently across the world, have been released after 1980. So the first 100 years of movies, much less than the last 40. That makes sense. It's a lot easier. Not easier, but a lot more people have cameras. A lot more movies being made. Let's just say that. So this gives you the fraction of whatever that's true. So we want to say the fraction that are comedy movies. And let's say fraction comedy is mean is comedy. In case we want to keep the counts, we could say count equals n. Remember that n function does count inside summaries. And now we will have x equals year, y equals fraction comedy. This fill isn't going to work anymore. We need to close the parentheses. Let's go ahead and adjust our y label, fraction comedy. Let's turn it into a percent. We just need to multiply by 100. Do that wherever we want. There we go. So we peaked around 1940. About 30% of movies were comedy. What was that? After World War II? When did World War II end? Uh-oh, during World War II. Okay, probably less movies then. And I guess people wanted to laugh. So 1940, we peaked. People were laughing a little less. In 2000, we had another little peak. And then we have had a drop since then. So 2020, you can see 2020 here. But it was maybe before 2020. I don't know if this might be due to the pandemic. Maybe not. Maybe the pandemic made the comedy movies come back a bit, because we got a little bit of a rebound. So we showed this area plot, we showed the percentage. One thing that's nice is to actually make it add up to 100%. So then we need to stack the comedy with the not comedy. So let's try to do that. So really what I would like to do is go back to this one, but I want to turn it into proportions so it adds up to 100%. So let's think about the easiest way to do this. Now, your favorite chatbot, this is probably one that it would come up with real quick, but I would like to think, because thinking is good. So let's see what we have. Let's look at our group by. Group by year is comedy. We could always mutate after that to give you the percentage of that count in that year. So that would give you the percentage of comedy and the percentage of other for each year. So that's one way to do it. I think if we think of another way that's a little easier, but that's kind of easy enough. All right, so I don't love this, but it's gonna work. What we will do, we will create a comedy column, percentage of each year that's comedy, percentage that's not comedy, and then we are going to do a little pivot longer to turn that into one column. And the reason we do that is that we can then have this one column where it says this is the percentage that is the comedy. So Phil is yes comedy, or Phil is yes comedy or not comedy. So let's just say comedy for each year is that, other is mean not is comedy, or you could do 1 minus mean is comedy. That would work just fine. And let's go ahead and do percentages. So we'll make them both times 100. And then we need to pivot longer. So we want to use every column except year. And actually, let's just see what we got so far, right? So first there were 0% comedy, then you can have a 1900. There was 14% comedy, 85% were not. Okay, so we are gonna pivot longer. So we only stack these two columns on each other. So minus year, and then we're gonna say names to, let's say, is comedy. So that will be the column name. Values to will be percentage, because that will be the number. Let's see what that looks like. This is the same thing, except we've changed our comedy and other columns. Now they're in one column. So 1894, there were no comedies, there were 100% other. Now we can make our area plot, and this will be perfect. Okay, so we need to adjust this so it's what we want. Names to is comedy, so now we have percentage is going to be Y for our area plot. The fill will be is comedy. And now let's go ahead and say proportion of comedy movies over time. We will change our YLab percentage. Apparently this is not a good data frame, and that is because I forgot to pipe it. There we go. We have comedy on top, other on bottom. I kind of want to flip it. I want to say percentage that is comedy. It's easier to see the numbers for the one that's on bottom. All right, so we're getting there. I am going to mutate. We are going to make is comedy into a factor, and we want it actually goes in backwards order. So the first one is on top, the last one is on bottom, other, and then comedy. Type that, let's correct it, and then let's pipe it. There we go. Oh, yes, yes, that is good. All right, so now we have what we want. I'm just gonna make it look nicer. Looks ugly. Okay, again, we can still see we peaked at about 30%, but most movies are not comedy movies. Now, again, you don't necessarily need to show it this way. If you wanted to just blow up the area plot and show it going up to 30%, that is just fine. And that might even be better. But this way, we kind of show the whole context. We show that for the most part, most movies are not comedy movies, but a lot more than there used to be. Let's go ahead and add a theme. Black and white works. We don't really want those grid lines. We'll see how the grid lines look. Actually, if we add a little alpha, might make the grid lines look better. Let's add alpha. Let's also add a little outline. So alpha is transparency. Since we are setting alpha specifically, we will not put it in an AES function. Remember, AES is when we are using a column to set our graph. So the year column of the data set becomes the x-axis. The is comedy column becomes the fill. If we just want to set the alpha, we'll say alpha equals 0.5, let's say. And let's also add an outline using color. So fill is the fill, color is for the outline. Looking better. Now we get this fill. We can see our grid lines. That kind of helps. We can see where we passed 25%. We dropped a little bit. This is decent, not terrible. Instead of having this legend, we could just label in the graph, and we could just make those labels manually. So I want to put one label here. Let's put it at 2000. Maybe we could even put it in the middle. Yeah, let's put it in the middle. 1960. We'll say comedy here. We'll say other movies here, just so people can see. Most movies aren't comedy movies. A lot of movies are though. So I'm going to add geom text. And this one, instead of using the data frame that was piped in, I'm going to set a new data frame. Data frame year equals, let's just put them both at 1940. We need to set where we want them on the y-axis. So we're actually going to set a percentage for the label. We'll put them, let's just try 10 and 70%, just a guess. And then what do we actually want the label to be? Label equals C. So the low one is going to be comedy. High one is going to be other. Now the nice thing is our AES is going to work, except I bet it won't find this fill. So we are going to put this fill inside our geom area. We need to make our own separate AES that applies only to the area plot and does not apply to the text, because this column does not exist in our special little label data frame. Let's add an AES function. So it's going to inherit year and percentage from the ggplot function, but we just need to say label equals label. So the label will be this label, percentage not found. That is because this was capital. Let's remove this legend now because we have a label. Comedy, other. Let's also change the colors. We're gonna make other gray because other movies are boring. Comedy movies are fun. So that is where we're gonna end it. Plus, guides, fill equals false. That gets rid of the legend. Let's go ahead and move this label over a smidge. We want a 1960, not 1940. And finally, let us change our colors using scale color manual. We need to set values to a vector. So other is first. You can see our levels are other first and then comedy. Let's say gray. Let's try gray 50 with an E because I'm British. Purple. Oh, I did scale color and not scale fill, and I forgot plus sign. There's a lot of things we could do to make this really, really polished up and perfect, but I think this is where we are going to leave it for today because I am tired and hungry. What have we done? We have shown comedy movies peaked around 1940, leveled off around 20% of movies every year, but then near 2020 we lost some comedy movies and decreased to about 12%. Hopefully a rebound is on the way. What else would I do with this if I had more time? Improve the fonts, make it bold, make this title more interesting. Probably don't need this solid lineup here. Maybe I would just go back and show the comedy area chart. Remember that one instead of showing other. Maybe that part's not necessary. So many other things you could do. I want you to try to do them. Let me know in the comments what you do. If you want to post your code, that's even better. Help each other out. Finally, let's actually look online and see if someone has already done a better job on this. Are there fewer comedy movies than there used to be? What happened to comedy movies? So Reddit is wondering. comedy movies, right? So maybe they are still happening, but they're not making it to the theater, right? So few comedies in theaters, so the comedies are still coming out, but we're not getting the big blockbusters anymore. And if you want to look into this more, I believe you'll find they just don't quite make as much money, so the big studios aren't quite making them as much. But I hope there are more comedy movies in theaters soon. What about you? What is your favorite comedy movie? How did I mess up this graph? How would you make it better? Please get down there in the comments and let me know. If you have ideas for future shows, what questions you might want to ask using data, let me know that as well. I would certainly be interested in giving it a go. I thought this one would be easy-ish. I think it ended up being kind of hard. There were a lot of little tricks, nuances. We ended up going kind of lazy, but I think we still ended up doing a good job. Hopefully you learned something. But if you didn't, hopefully you had a little bit of fun, maybe. I think that's enough. What did I forget? Yeah, let's say we're done. Bye.